Hello everybody. Today we'll be doing a Usaco guide, bronze problem, block game in the simulation category. Farmer John is trying to teach his cows to read by giving them a set of N spelling boards typically used with preschoolers. Each board has a word and an image on each side. For example, one side might have the word cat along with the picture of a cat, and the other side might have the word dog along with the picture of a dog. When the boards are lying on the ground, N-words are therefore shown. By flipping over some of the boards, a different set of N-words can be exposed. To help the cows with their spelling, Farmer John wants to fashion a number of wooden blocks, each embossed with a single letter of the alphabet. He wants to make sufficiently many blocks of each letter so that no matter which set of N-words is exposed on the upward-facing boards, the cows will be able to spell all of these words using the blocks. For example, if N equals 3 and the words box, cat, and car were facing upwards, the cows would need at least one B block, one O block, one X block, two C blocks, two A blocks, one T block, and one R block. Please help the Farmer John determine the minimum amount of blocks for each letter of the alphabet that he needs to provide, so that irrespective of which face of each board is showing, the cows can spell all N visible words. And then this is just the input. Line 1 contains the integer N, and the next N line contains two words separated by space, and then the output is just all the alphabet, so A, B, C, D, and the number of blocks we need per each character. So this problem is pretty easy. I mean, it might seem difficult because you might think you need to find every single possible combination of words, but you don't really need to do that. So all we really need to do is just compare all the characters in the word pairs. So as we can see for fox and box, we just want to find, well, one, the unique characters, and then two, the maximum value of each unique character per word. So we could see that for fox and box, F is unique, B is unique, but then O shows up in both fox and box, and then X also shows up in both fox and box. But since they both only appear once in each word, we're only going to need one O block and one X block. But let's say that instead of fox and box, we have boo and box. So you like this and this. Well, we can see that B occurs in boo and box, but it only occurs once in both words, so we're only going to need one B block. And then X is unique to box, so we're just going to need one X block. But now we have O, and it shows up in both boo and box. But in boo, it shows up twice, versus where in box, it only shows up once. Well, since the maximum amount of O blocks that we will need to create one of the words is 2 O blocks, we're going to need to say that, hey, in the problem, we're going to need at least 2 O blocks, right? Because then you can't, without 2 O blocks, you can't spell out boo. And basically, you just need to do that for every single word pair. So for dog and cat, you're going to need a D block, O block, G block, C block, A block, and T block. And then for car, you're going to need a C block, A block, R block, B block, U block, and an S block. And basically by doing this, then we'll just add all of our results into a list, and then that list will give us the max amount of blocks that we need to create any pair of words. So the code for this is quite simple. So first, I'm just getting the input and then creating a list of 26 indexes, so then for all the alphabets, or all the letters in the alphabet. And you can ignore the function count for a second. So as we can see, we start with our for loop, and then we just get words 1 and 2, so fox and box. And now we're calling the count function. And basically all the count function is doing is it's just creating a dictionary of all characters in each respective word. So then for Fox, it'll show up something like this. Oh, F will be 0, comma, O will be O. O will be 1, and then X will be 1. And that's all it's really doing. It's just going through each character and then just putting it in a dictionary and then just stating how many times it occurs, right? So if instead of Fox it was Boo, it would just be B, and then you could see O occurs twice, so then it would just be 2. So yeah, that's all that function is really doing. And then what this syntax is really doing is it's just seeing if the value already exists, right? So if we have like 1, 2, some like value, then it'll just return that. And then if the value doesn't exist, it'll just set it to 0. And then we just, of course, want to increment it by 1. And then we're gonna call that twice for each word. And then we're gonna create a result dictionary, right? So then this will just check out it'll just combine the results from each one of them and then make sure that we have the lowest amount of blocks that would be required to create each word individually. So first we can see just this for loop, and then it goes through every character in word 1, and then it says, well, if this character is not in results, then we're just going to add it to results, and then we're going to get the max amount of occurrences that is seen in both word 1 and word 2, right? So if let's say the letter O was seen twice in dict 1 but only once in dict 2, then result at O would equal 2 because that's the max value. And then it's just doing the same for word 2. And then after all of that, you're just gonna enumerate or go through the dictionary, so you'll just have access to the keys and values. And then what I'm doing here is I'm taking the ASCII value of each character, right? So A starts from A's ASCII value is 97, and then B is 98, then C is 99, and then so on and so forth up until Z, right? So basically all it's doing is it's just converting the character into a number and then subtracting it by 97, because we want A to be the 0th index and then B to be the first, and then so on and so forth, right? And then we just add the value, right? So whatever we got from result, whatever was inside result. And then we just print out L1, and we can see that this does indeed work. Yep, it's a pretty simple solution. Thank you for watching.